Welcome back. Next, we'll be taking a look at the vector conditional. So up to this point in this module, we've just been checking when the single condition is true. So with vector conditional, we can basically pass in a list of conditions and return a list of true or false values. So if we compare the if-else statement with $, on our overloaded glyphs page here, we see we've got this conditional evaluation example. This is what we've been doing up to now. So you see we've got one condition, one true or false statement in here. And then by comparison, if we go to the question mark, which is our vector conditional, so it's this example here, you'll see we're passing in a list of true or falses, and then we've got a list output here for both our true and false statement. Okay, note you can have anything in the second and third parameter here for your true or false, but they must be of the same type. And let's see this in action now. So go back over to our Jupyter Notebook. So in this example here, I'm using my vector conditional. I'm passing in a list of booleans. Then I've got one list of longs and then another list. And if we run this, we'll see whenever there's a true. So for the first and last index, you'll see I get my first and last index of my true statement returned. And then for all of the falses, they're coming from the indexes of the false statement. Okay. So you can also have any of these values to be a single atomic value. So for example, I'm changing my second parameter here to be 1. And basically it will just repeat that value 1 anywhere where it's needed. And then also note when it's not an atom and you've got a list, all of these lists must equal the same length. So for example here, I've changed my last parameter to be 4 values long rather than 5. And if I run this, I'm going to get a length error. Okay, so you must ensure these are all the same length when they're not atomic. And if they are all atomic, that's still the same as using our if-else statement. So if we copy and paste this and we do just 1b for that and then change this to be 10, you'll see I'm getting 1 back from that. And if I change this to be my if-else statement, and then if we flip these to be false, you'll see we get the false statement returned. So they're very similar in syntax. The only difference is obviously that I can pass a list here, whereas for my if-else statement, I'm unable to pass a list. I'll get a type error. Okay, so we can do some really useful things with this. One example would be capping a list at some maximum value. So in this example here, we're creating a function called cap at max, and I'm passing it 2 parameters. So the first one is my vector and the second one is the cap that I want to apply. And then if I create a list of vectors of 30 random values, then we're basically checking if our vector exceeds our cap, we want to replace it with cap, otherwise leave the vector value in place. So let's just output vec greater than 12 here. So you'll see my first 3 are greater than 12 and I'm getting trues returned. And for the ones that are less than 12, I get zeros. And then you'll see in my vector list, when it runs through this function, the first 3 values have been replaced by 12 because of this condition. And then my values after that are below 12 remain as zeros and so on. Okay, so this kind of thing is done very commonly when we use QSQL queries. And that's because columns in a table are really just lists. So if we take an example that's quite common, which is a financial use case. So say we have a field that is indicating the side, so whether it's a buy or sell side, we want to then populate another column with either the bid or ask value depending on this side. So we're conditionally updating a new column depending on this one here. So to do that, we can use our vector conditional and we can pass in this single check, so whether the side equals buy, and then we're going to fill it in with either the asks or the bids depending on that. So if we define this first of all and then run this, you'll see we get the 2 ask values back in the first 2 indexes, and that's because they're both buys. And then when it's not buy here, we get this 12.2 value back. And I'll also just show the table notation version of that. So if we define a table like this, so this is our table notation in Q, we have round brackets and then square brackets, and then I'm just going to paste in my columns that I want to be in that table, and I need to separate them with the semicolon and just ensure to indent this a little bit so Jupyter doesn't give out. Okay, so now I've got a table T, and this will look like so. The way you can tell it's a table visually is by this horizontal dotted line, and then these are my 3 columns: side, bids, and asks. So let's say I want to add on a 4th column. We're going to update it with the new value, for example, and we want to fill it in with our vector conditional. And then we'll say from T. So this is our QSQL update statement. And if I run that, you'll see I've got a 4th column added on called new value, which has got 10.4 and 10.5. So the ask values when it's buy, and then I've got 12.2 when it's a sell. So you can see hopefully how useful that can be when you're updating a new column or an existing column that is based off the values in another column. So don't worry too much about this table notation or the QSQL statement. We will be going into that in a lot more detail in our tables module later on. But I just want to show a quick example here because I'd say it's probably the most common use case of the vector conditional. So it's nice to see it in action. So have a go with this exercise, so creating this list L, and then use the vector conditional to fill in the null value at 10. So we know we've filled in null values previously a number of different ways in our other modules, and in this example we want you to specifically use the vector conditional. Okay, have a go with that, and I'll see you back in the next video.